Welcome to qnawire.
In this question, okay, this is a situation. So before we have block L and R, and they are connected by a spring which is compressed initially. L is 1 kg, R is 0.5 kg. Okay, and after that, okay, they are released from rest. So L moves to the left with a velocity with a speed VL. R moves to the right with speed VR. Okay, so we are given that VL is 1.2 meters per second relative to the floor. Okay, there are two parts in the question. In part A, we are given VL is 1.2 meters per second relative to the floor. Okay, we want to find the distance traveled by block R in 0.8 seconds. Okay, so this question itself is trying to bring out the importance of the word relative. Okay, so in part A, we are given that block L is moving at 1.2 meters per second relative to the floor, and in part B, we are given that block L is traveling has a speed of 1.2 meters per second relative to block R. Okay, so and we want to find the distance traveled by block R in 0.8 seconds. Okay, so in part A, VL is 1.2 meters per second relative to the floor, and we can just use conservation of momentum to find VR. Okay, so initially the whole system is at rest. 0 is equal to ml VL plus mr VR. Okay, going to take to the left, right as positive. Okay, so we have VR equals to minus ml VL divided by mr. Okay, so we have minus 1 times negative 1.2 divided by 0.5. So velocity or speed of r is 2.4 meters per second. Okay, and the distance traveled by block R is equal to VR times delta t, which is 2.4 times 0.8 and 1.92 meters. Okay, so in part A, block R travels 1.92 meters, okay, in 0.8 seconds. Okay, in part B, we are given that block L travels at a speed of 1.2 meters per second relative to block R. Okay, so we will write this equation VL minus VR is equal to 1.2. Okay, however, since VL is to the left, okay, so VL is itself negative, okay, because we take right to be the positive. So actually VL minus VR should be negative 1.2. Okay, yeah, so I think this is how you should write the first line. Okay, all right, so using conservation of momentum, okay, so for this we can write VL equals to VR minus 1.2. Okay, then so same thing as before, 0 equals to ml VL plus mr VR. Okay, and then this is ml times VR minus 1.2, and then we have mr VR. Okay, so VR is 1.2 ml divided by ml plus mr. Okay, you can put in the numbers, and you get 0.8 meters per second. Okay, so the distance traveled by r is equal to the speed of r times delta t. Okay, 0.8 times 0.8 is equal to 0.64 meters. Okay, so this is the answer for part B, and that's all for this question.